Let's take a look at this example. This time it looks like we have to find every single current in this circuit. So what we're supposed to do, we're supposed to start from finding the current through each resistor. Why we're supposed to start from it? Because we have voltage source given, we have value of each resistor, so I believe this is a good start. So I'm going to use Ohm's law, okay? So just keep in mind, first of all, before I'm going to start, that V1, this is KVL, V1 is equal VR1, this is also equal VR2, this is also equal VR3, and this is also equal VR4, and this is equal 10 volts. Why? Because all resistors are connected directly across the voltage source, okay? So R1 is connected to voltage source, R2 is connected directly to voltage source, R3 and R4. That's why we say that the voltage across each resistor is equal to the voltage source. Now I'm going to find the current IR1, which is equal VR1 over R1. This is equal 10 volts over 3.3 kilo ohms. Okay, let's check the calculator. We have 10 divided by 3.3 exponent 3 is equal 3.03 milliamps. Okay, so this is my current which will go through resistor R2. Next, current which will go through resistor R1. Next, I'm supposed to find the current which will go through resistor R2. IR2 is equal VR2 over R2, which is equal 10 volts over 4.7 kilo ohms. This is equal 10 divided by 4.7 exponent 3. This is equal to 2.12 milliamps. Okay, please notice that when we have lower resistance, okay, higher current is going to go through that resistor. Okay, when we have higher resistance, the smaller current will go through that resistor. We have to keep in mind that current is very lazy guy, and it always looks for the opportunity to reach the ground. Okay, it's supposed to reach the ground in the easiest way, okay, in the shortest way. So if there is no resistance, the highest current is going to go through that branch. Okay, so now let's take a look at the resistor R3. So I have IR3 is equal VR3 over R3, which is equal 10 volts over 9.1 kilo ohms. Okay, so I have 10 divided by 9.1 exponent 3 is equal 1.09. We can say 1.1 milliamps. So I have 1.1 milliamps. And we have IR4, which is equal VR4 over R4, which is equal 10 volts over 5.2 kilo ohms. So this is equal 10 divided by 5.2 exponent 3. This is equal 1.92 milliamps. Okay. So let's take a look what we have over here. The highest resistance in this circuit was 9.1 kilo ohms. That's why the current which goes through this resistor is the lowest one. Okay, so please notice one more time that when we have a parallel circuit, the highest current will go always through the lowest resistance. So R1 is the lowest one, okay, has the lowest value. That's why my IR1 is the highest current in the circuit, okay, and R3 has the highest value, okay, highest resistance, 9.1. That's why the current is the lowest one, okay. So next we're supposed to realize that we have already IR4. We found this current, okay. This current is IR4, and we found it. This is 1.92 milliamps. Next, I'm supposed to find the current, okay. The current I let's call this R3 4, okay. So this is the sum of these two currents, okay, because this current is going to split into current IR3 and IR4. So IR3 4 is equal IR3 plus IR4. IR3 is equal 1.1 milliamps plus IR4, which is equal 1.92 milliamps. Okay, so I have 1.1 exponent 3 negative plus 1.92 exponent 3 negative. Okay, and this is my current, 3.02 milliamps. Okay, so this is the current which will go, okay, through this connection. Now please keep in mind that if this current is 3.02, okay, so this current is going to be also the same, okay, so this is IR3 4, okay, so if this one is 3.02 milliamps, okay, and it's going to split into two currents, these two currents are going to come back again together, okay, and it's going to give me, and they're going to create again current 3.02 milliamps. Okay, so next we're supposed to find the current which goes through this junction, okay, so we have, this is going to be current IR2 3 4, okay, so IR2 3 4 is equal IR2 plus IR3 4, okay, so this is this current plus this current will give me this current, okay, IR2 plus IR3 4 will give me this current. IR2 we've found is equal 2.12 milliamps plus IR3 4 we've found is equal 3.02 milliamps. Okay, so we can use the calculator. So this is 2.12 exponent 3 negative plus 3.02 exponent 3 negative. This is equal 5.14 milliamps. Okay, so this is current I2 3 4. Okay, I have to move this up. So next we're supposed to realize that this current is going to be exactly the same current, because this current is going to split into three currents, okay, and these three currents are going to come back together and create again IR2 3 4, which has the value of 5.14 milliamps. Next I'm supposed to find I total. This is my I total, okay, this is I total and this is also I total. So if I want to find I total is simply the sum of the currents IR1 and IR2 3 4. Okay, so I have to add these two currents, okay, this current is going to split into two currents, IR1 and I are 2, 3, 4. So we have I total is equal I R1 plus I R2, 3, 4. Okay, and this is equal. IR1 is, we found, is equal 3.03 milliamps. Okay, so this is 3.03 milliamps plus IR234, which is equal 5.14 milliamps. Okay, so again we are going to practice the calculator. We have very simple calculations, but you know, calculator is extremely important. So I have 3.03 exponent 3 negative plus 5.14 exponent 3 negative. Okay, this is equal 8.17 milliamps. Okay, so this is 8.17 milliamps. This is the value of my total current. Okay, so now let's verify if our answer is correct. Okay, I'm going to find I total in a little bit different way, and I'm going to compare the values of I total, and I'm going to check if the answers which we got are correct. So I'm going to find R total first. R total is equal 1 over, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Okay, so this is equal 1 divided by, open parenthesis, 1 divided by 3.3 kilo ohms plus 1 divided by 4.7 kilo ohms plus 1 divided by 9.1 kilo ohms plus 1 divided by 5.2 kilo ohms. Okay, so I have R total is equal, I use the calculator, so I have 1 divided by, open parenthesis, 1 divided by 3.3 exponent 3 plus 1 divided by 4.7 exponent 3 plus 1 divided by 9.1 exponent 3 plus 1 divided by 5.2 exponent 3. Close parenthesis, this is equal 1.22 kilo ohms, 1.22 kilo ohms, 1.22 kilo ohms. What it means that this circuit could be replaced by a circuit which looks like this. We have voltage source, which is V1, and we have resistance R total, which is equal 1.22 kilo ohms. Okay, so I can simply say that these two networks are equivalent. So next I'm going to find I total. I total is equal V1 over R total. V1 is equal 10 volts over 1.22 kilo ohms. So I have 10 divided by 1.22 exponent 3 equals 8.19 milliamps. 8.19 milliamps. Now compare this value and this one. Okay, they are very close to each other. So it means that all results which we obtain in these calculations are correct, and basically these values are the solutions to this problem.